Hi and welcome to Math Foundations 20, Section 5.4, the normal distribution, Example 1. Okay, so in this question, we've got the speeds of 1,000 cars were recorded. If the data collected was normally distributed, with a mean of 105 kilometers per hour and a standard deviation of 10 kilometers per hour, determine, Part A, the percent of cars going between 105 kilometers per hour and 115 kilometers per hour. Okay, so the key here is this data is normally distributed. If it wasn't, there's nothing we'd be able to do with this. But since it is, we can take this information we're given, the 105 and the 10, and use that to label a normal curve. So we have this curve here, it's the normal shape, and our mean is 105. What we know about the normal curve is the mean is the peak, it's the middle of our data. And then we have a standard deviation of 10. So that means this line here is 105 plus 10. This one here is going to be another 10. So that's 2 standard deviations above. So basically when we have a question like this, we just make the normal curve and we label these different lines. This one here is 10 below, so it's 95, and then 10 below that, 85. Okay. So now we can use this to answer questions. Basically, once we get that, we can answer questions. So it's asking for the percent of cars going between 105 kilometers per hour and 115 kilometers per hour. So we want to know the percent of cars in this area here. Well, we know from the normal curve that we had just looked at, right, that between the mean and one standard deviation is 34% of the data. So that's just the answer to this question. 34% of the cars are going between 105 and 115 kilometers per hour. So if we know the normal curve, we know these values off of the normal curve, right? So we're looking at the values here along the bottom. Right? If we know these, right, then we can answer these questions because this set of data is, again, right, it's normally distributed. Okay, part B. The percent of cars going less than 115 kilometers per hour. Okay, well, we know that we have, I'm going to erase what we have here. Okay, so we know that we have 34% of the cars in here, so those ones are going less than 115, and we also know that half of our data lies on this side of the mean. So if half of our data is on that side of the mean, that's 50% of our data. So basically we have 50% of the data there plus 34% of the data there. So how many cars, or what's the percent of the cars? Well, 84% of the cars are going less than 115 kilometers per hour. Right, and so that's based on the 34% and the fact that the other side is 50% of the data. You could go through and add up each individual one there, right, the 34% in here, and so forth, or you can recognize that that whole thing is going to be 50. Okay, looking at part C, so the percent of cars going over 125, so again I'm just going to quickly relabel this. This is 105, 115, 125. So the percent of cars going over 125, so that's from 2 standard deviations and above. So going back to the normal curve here, 2 standard deviations is this line here. Everything above we've got 2.35% and 0.15%. So we're just going to add those two, right, which gives us 2.5% of the cars. Okay, so basically looking at this here again, it's not just the 2.35%, it's everything from this red line onwards, so 2.35 and the 0.15. Okay, the 0.15 takes into account everything from here on. Okay, and then part D, the number of cars going between 115 and 125. So that's looking in this area here. Right, so what percent goes in there? Well, we go back to this, and it's the 13.5%. It's the between 1 standard deviation and 2 standard deviations. So we said that's 13.5%. Okay, so 13.5% of the cars are in there, but ding ding ding, there's an issue here. The question says the number of cars. So we don't want just the percentage, we want the number. So we have 13.5% of the cars, and how many cars were there? Well, the question said there was 1,000 cars. So to find the actual number there, we're going to go 1,000 cars times by 13.5%, and to multiply by a percent, where we convert it to a decimal of 0.135%. No, not percent, sorry, of 0.135. And we calculate that, and we should get 135 cars. Alright, so the key to that one, is the fact that over here, it asked for the number of cars, not the percent of cars. Okay, so that's how we can apply the normal distribution curve to answer some questions. Okay, and that, again, that's due to the fact that it is normally distributed. Oh, if it wasn't normally distributed, we wouldn't be able to do that. Okay, thanks for watching.